Previously on Narculus. A lowly math teacher who taught 25 students per period wanted to teach calculus to more students. So he created Narculus, and soon a star was born. His videos have now been seen all over the world, or at least as far as some of South Plainfield, and are as popular as other YouTube videos, such as Dog Wins Tug of War with Tree Branch, How to Save a Google Doc, and Cat Rides Roomba Vacuum Cleaner Like a Boss. Ha, that one's funny. It's a cat that rides in circles on a vacuum cleaner. Now, prepare yourselves, because it's time for the season finale of Narculus. Hello, thanks for clicking. Today, we are here to talk about inverse trig and the inverse trig derivatives. Some of the stuff that we're going to talk about today you learned last year, and some of the stuff will be brand new this year in this season finale of a Narculus production. Dun, 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 dun. All right, let's get this show on the road. Last year you learned about inverse trig and its notation, as well as how to calculate inverse trig. So the first thing that you learned in trig was you learned that, for example, you learned your unit circle, you learned that the sine of pi over 6 was a half, and you learned a bunch of different things about the unit circle. And then later on we said, oh, well, there's this concept of inverse, or inverse trig, where you switch your x and y, and now instead of me giving you an angle and you telling me which point or ratio it is on the unit circle, I'll give you a point on the unit circle and you tell me which angle it belongs to. So, for example, last year, what you learned was you learned a brand new notation for inverse trig. The notation that you learned was probably this one, y equals the inverse sine of x, okay? Or you could have learned this one, y equals the arc sine of x. Both of these mean exactly the same thing. All right, both of these mean the same thing, and on the AP exam they can use them interchangeably. So you do have to understand that both of these mean inverse trig, okay, or in this case the inverse sine. So what they asked you for was they would ask you what is the inverse sine of a half, and you would tell them, oh, okay, so which angle is that? That's pi over 6. And your answer would be pi over 6. Now, the issue is, if you remember your unit circle, which you should, the problem is, this is not the only place that sine has a ratio of a half, right? There's another place, it's 5 pi over 6. But we don't accept 5 pi over 6 as an answer. So my first question to you, which I want to know the answer to tomorrow, is why don't we accept pi over 6 and 5 pi over 6 both as being acceptable answers? Okay? We said, no, you can't accept two different answers. There's got to be a reason for that, and you guys should know what that reason is. So come in with an answer tomorrow. So what we did then as a result after this was we said, okay, well then we're going to take all of the inverse trig functions and we're going to restrict them. So you had different restrictions on all the trig functions. If we start with, and we rewrite them just so that you remember them from last year, for arc sine x, the y value, the range, has to go between negative pi over 2 and pi over 2. The arc cosine of x runs between 0 and pi. The arc tan of x runs between negative pi over 2 and pi over 2. And then over here on the other side, we'll do the arc cosecant, which runs between negative pi over 2 and pi over 2, but y can't be 0. All right, so if you allow me here, I did make one mistake here. Let me just clear that up. We can't have the arctan of pi over 2 or negative pi over 2 because they're going to be undefined there. So get rid of your equal signs down here. Okay, they're no good. All right, over here we're okay. And then we have the arc secant is from 0 to pi, but y can't be pi over 2. And finally, we have the arc cotangent, which runs between 0 and pi, not including 0 or pi, because that's where there are going to be asymptotes. Okay? So my next question to you is, I understand, or I told you that these are your ranges, these are the answers that you could possibly give me for inverse trig, but my question is, why are we only restricting these trig functions to, in essence, 2 quadrants? And why these restrictions? Why are these the restrictions that we put on each one of these inverse trig functions? Okay, so another question for you to answer for me tomorrow. So, for example, you learned this last year, before we get to what we really want to learn, which is the derivatives. If I ask you for the arc tan of -1, well, the arctan of -1, you got to figure out where the tangent would be 1, first of all, and that would be at pi over 4, right? Your reference angle is pi over 4 there. But where's the arctan -1? Well, you're going to have to go into quadrant 4 to find that, but you're going to have to use a negative angle, so we would say it's negative pi over 4. Don't tell me that it's 7 pi over 4, okay? That is wrong. All right? Don't tell me it's pi over 4. That's wrong too, because tangent is not 1, or tangent is not -1 at pi over 4. Okay? So don't tell me pi over 4, it's negative pi over 4. And that's the answer you have to give me. These restrictions are important. You should know them because they will ask you to evaluate inverse trig, even in calculus, because there are some things you do have to evaluate it for. And we'll see one coming up in a few minutes. But before we do that, let's start doing some calculus, since none of this really is. And let's start finding the derivatives of all of these inverse trig functions. So let's start with one. Let's start with the arc sine. I want you to find for me the derivative of arc sine x. Well, that would be fine, except there's no rule for it, and I didn't teach you a rule for it. So you're kind of out of luck right now. So the first thing that we are going to do is we got to be able to figure out some way to get the rule. So to do that, the first step I'm going to take is I'm going to take the sign on both sides of the equation. Okay, there's a reason for that. There's a reason I'm choosing to take the sign on both sides. So now we have the sine of y equals this mess. Sine of arc sine of x. Now if you think about this right-hand side, and you can do an example to convince yourself that it's true. I'll do it over here. If I ask you for the sine of arc sine of a half, well, you tell me, oh, well, I know the arc sine of a half, that's in parentheses. Arc sine of a half, that's pi over 6. And then the sine of pi over 6, well, that's just a half. Because this says, what point do I get for pi over 6? So if you think about this relationship here, sine of the arc sine of a half, okay, no matter what point I put in here, radical 3 over 2, 1, you name it, I'm going to get back to this answer eventually after I do all the math. So the sine of the arc sine of x is simply x. Now, this is great because arc sine is completely gone from my equation, and now I can derive it, right? It's implicit because y is stuck inside the function, but I can still find the derivative. The derivative of sine y is cosine y. Well, you derived the y, so you need a dy dx. And the derivative of x is 1. So I solve this then. I know dy dx is just equal to 1 over cosine y, which would be okay. Except I don't want my answer in terms of y, I want it in terms of x. Because I started with y equals arc sine x. So the question is, how do I take this and rewrite it in terms of x? So if you look back up here, sine y is equal to x. Well, that actually leads you to a right triangle. When the angle measure is y, sine is opposite over hypotenuse. So you have x over 1. So the opposite side is x, the hypotenuse is 1. So I can find this side pretty easy. I'll call it a. So to do that, we just have a squared plus x squared equals 1 squared. So a equals the square root of 1 minus x squared. Right? It has to be the positive branch, right, of 1 minus x, radical 1 minus x squared. Because we're talking about a triangle, it's got positive measure. Okay? You can't talk about a negative here. All right? So now, that helps because I can figure out the cosine of y. The cosine of this angle is going to be adjacent over hypotenuse. So cosine y is just going to be radical 1 minus x squared over 1. But this over 1 is just radical 1 minus x squared. And this is the derivative of the arc sine. And this is the rule that's been proved, yeah? So we've just proved the rule, okay? All it took was a little bit of pre-calc and a little algebra over here, right? All right, so now let's put all these rules up here in one nice place so that you have them all in the same place. There are 6 rules here, one for each inverse trig function, okay? There's an easy way to figure them all out. You really only have to know 3 of them, though, which isn't so bad. The derivative of the arc sine is 1 over the square root of 1 minus x squared. That's the one we just proved. Times the derivative of x with the chain rule, the derivative of the argument. All right. Now I'm going to write them maybe differently than you thought I would. The derivative of arctangent is 1 over 1 plus x squared times the derivative of the argument with the chain rule. The derivative of arcsecant is 1 over x radical x squared minus 1 times the derivative of the argument with the chain rule. Remember, we're deriving, so we need the chain rule, okay, not substitution. Now, let's go and write all the cofunctions next to them. So the derivative of arc cosine, the cofunction of sine, is negative 1 over radical 1 minus x squared times the derivative of the argument with the chain rule. The derivative of the arc cotan, which is the cofunction to tangent, is negative 1 over 1 plus x squared times the derivative of the argument. And the derivative of the arc cosecant is negative 1 over x radical x squared minus 1 times the derivative of the argument with the chain rule. So these are our 6 rules. Now you can see that if you know the 3 on the left, then their cofunctions are all the same rule, but they're all negative. So my first question, I have 2 questions about the rules that are here. Number 1, I'd like for you to prove to me that the derivative of the arctangent is 1 over 1 plus x squared. Just like we just did arc sine, I'd like you to prove this rule to me. Okay, show me that this rule works. And number 2, I want to know why all of these cofunctions happen to be negatives. And there is a reason for it, and it's a pretty simple reason. If you actually start trying to derive it, you might see why all of these functions, cofunctions, have negatives in them as opposed to these guys, which all have positives. All right? But these are your 6 rules. You do have to know them. Okay? They will be on the exam. And just so you guys know, these x's that are here are referring to the argument of the trig function. So arcsecant, if this were to say arcsecant 6x, then I would put a 6x here, a 6x there, and derive the 6x with the chain rule. Okay? So these x's refer to the argument of whatever the inverse trig function is. All right? All right, so we're going to try a couple. I'm going to erase these, and we'll try a few just to make sure you guys got the hang of it. Okay? Like I said, once you know the rules, it's actually not complicated. All right? And again, those 2 questions I want answered for tomorrow. Let's start with f of x equals x squared arc sine of 2x cubed. All right, that doesn't matter. Once you get the hang of it, once you know the rule, you can do it. So this is a product rule problem. So we're going to leave the x squared. The derivative of arc sine of 2x cubed is going to be 1 over the square root of 1 minus the argument squared times derive the argument with the chain rule, 6x squared. Okay? Plus, leave the arc sine of 2x cubed, and the derivative of x squared is a 2x. Oops. All right. Now I'm going to try to clean this up. So it's all algebra now. There's no more calculus. My responsibility is done. It's done up here. Excuse me. All right, so now we're going to clean this up. We got 6x to the 4th on the top. Underneath, we have a radical 1 minus 4x to the 6th plus 2x arc sine of 2x cubed. We need a common denominator. The common denominator is the square root of 1 minus 4x to the 6th. I'm going to save myself a little trouble. I'm going to factor out a 2x in the numerator while I'm putting the radical 1 minus 4x to the 6th in this term. So take out the 2x. You're left with a 3x cubed plus arc sine of 2x cubed times the square root of 1 minus 4x to the 6th. And that's the correct answer. All this underneath it. Okay? And that's your right answer. It looks complicated. The rules are complicated. They're not difficult. They're just complicated looking. All right? And then it gives you then a complicated answer. Okay? All right, so that's the first one. Hopefully not too bad for you. Like I said, once you get the hang of it, you know, at this point you guys have derived who knows how many questions. So shouldn't be too bad to do. All right, let's try another one just to make sure that you get the idea. Let's try 8 arc secant of 6x. So you're going to derive this, leave the 8 out of it. The derivative of arc secant of 6x is 1 over 6x times the square root of 6x squared minus 1 times 6 with the chain rule. And now you're going to clean it up. That crosses out with that. So f prime is equal to 8 over the square root of 36x squared minus 1. And that's it. You're done. Okay? So hopefully so far so good. Nothing too fancy here. And finally, we'll do one more. We'll do a small application. I want you to write the equation of the tangent line for f of x equals 3 arc cosine of x over 4 at x equals 2. Okay, I want you to write for me the equation of the tangent line. All right, well, we need two things, a point and a slope. All right, so let's go find the slope first. So let's find the derivative of this guy. The derivative is, leave the 3 out of it, the derivative of arc cosine x over 4. Cosine is the cofunction of sine. So it has the same rule as arc sine, but it's a negative. So you're going to have negative 1 over the square root of 1 minus x over 4 squared times the derivative of x over 4 is a quarter. All right? So now we're going to try to clean this up. So f prime of 2, just take the number, plug it in. You got negative 3 over 4 square root of 1 minus 2 over 4 squared. So that's negative 3 over 4 square root of 3/4. Okay? So far so good. All right? This is a half squared is a quarter, 1 minus a quarter, 3/4. All right, I'm going to take the square root of each one of those that's underneath. And then I'm going to say that's negative 3 over 2 root 3. And they will allow that. They'll allow you to leave that on the exam. You don't have to rationalize. It's not one of the guidelines. There's your slope, negative 3 over 2 root 3. Now, I also need a point to go with it. So to get the point, I just got to take 2 and plug it into the original. So f of 2 is 3 arc cosine of 2 over 4. So that's 3 arc cosine of a half. The arc cosine of a half. So where is cosine a half? That's at pi over 3. And you get pi. So there's a point at 2 comma pi. So I have an answer then. I have a line. It's y minus pi equals negative 3 over 2 root 3 is my slope, x minus 2. And that's my equation of the line, and that's what I'm looking for. Okay? So a couple of things that you can notice here. Number one, you do have to be able to evaluate inverse trig, so that means you have to know the restrictions on the range that we talked about earlier, all right, to be able to evaluate these guys properly. okay, and not be writing down answers that you cannot write down. All right. And the other thing, which I didn't really do much of here, and I certainly could have, is I could have obviously asked you to do the same problem, okay, at the beginning by asking you this, giving you this function 3 inverse cosine of x over 4, and say, okay, do the same thing. Remember, this rule and this rule are exactly the same. All right, they mean exactly the same thing. Their rules are exactly the same. Okay, in our textbook they use arc cosine, but again on the exam they can use both interchangeably. They can use inverse cosine and arc cosine interchangeably. So you do have to know that both of them mean the same thing. All right, and they're asking you the same question. Okay, that's really all there is here. It's just 6 more rules, and that's really it. I know the rules are semi-complicated. Okay. I'll see if I can find a friend or somebody who might be able to help us to remember them. I don't know, I'll ask around, see if anybody famous can help us. And that's really all there is here. So, from me to all of you, I just want to say I hope you had a wonderful time watching today's season finale of Narculus. And thanks for clicking. Good talk.